This video will show how to create contour, hillside, slope, and aspect from a digital elevation model. The data that I'm using here is the digital elevation model of Kathmandu, where we will first clip that into Kathmandu Valley Watershed using a boundary layer. So first of all, let's go to new map. And let's go to view, catalog pane. And here we connect our folder where we have the DEM and boundary layer. So this is the DEM that I'll be using. So I'll just drag and drop that here. Okay. Yep. And then we have watershed boundary. So we'll keep that here. So we will first clip this. So for that, let's go to geoprocessing. Clip raster. It's in the data management tools inside geoprocessing. So we click that. So here in toolbox, in raster processing, we have this clip raster. We click it here. Input raster would be the entire DEM, and the output extent would be the Kathmandu Valley Watershed. And we will use the input features for clipping geometry, and then we run. So here we get the digital elevation model for Kathmandu. Now we don't need this layer, so we remove this. We change the layer name to DEM clipped so that it's readable. And also we go to symbology for this watershed boundary, and then we make the layer transparent so that it's easy to read or easy to see. Now that's how we load digital elevation model that we downloaded. Now using this digital elevation model, we are gonna generate contour, hillside, slope, and aspect. So first we go to contour. For this, we go to geoprocessing. And in geoprocessing, we have spatial analyst tools. And inside spatial analyst tools, we go to surface, and then we go to contour. Here our input raster would be the clip DEM, and output would be contour. And the contour interval that I'm keeping here is 200. Contour type would be contour, and then run. So this contour function generates contour lines by joining points with the same elevation from a raster elevation layer. The contour are isolines created as raster for visualization. Now we go to, our contour line has been loaded. So now we go to symbology. And here we go to graduated colors. And the field should be changed to contour. Line denotes elevation that is below 1400, and the red line shows elevation that is between 2200 and 2600. We change the decimal places to 2 or 0 to make this more readable. So that was for contour. Now we go to hillside. So for that, we again go to geoprocessing and we go to hillside. The input raster would be the clip DEM and the output would be hillside, and we run. So this hillside function produces a grayscale 3D representation of the terrain surface where a lighting effect is added to a map based on elevation variations within a landscape. This helps in visualizing terrains and landforms in that particular watershed. So we go to symbology again and we change the color here for better representation. Now the third thing that we are seeing is slope. So we go again to geoprocessing, spatial analyst tools, and we go to slope here. The input raster would again be the clip digital elevation model, and the output raster would be slope here. And the output measurement, we want to have this in percent rise, and then run. So this slope tool identifies the steepness at each cell of a raster surface. The lower the slope value, the flatter the terrain. The higher the slope value, the steeper the terrain. So we can see here in the central part of the watershed, the slope value is lower, so the terrain is flatter. And in the outskirts, we can see the slope value is higher, so the terrain is steeper here. In the same way, we go again to geoprocessing and we calculate the aspect. So again, the digital elevation model, aspect, and run. So the aspect tool identifies the direction of the slope. An aspect is given in degrees from 0 to 360 degree, where north is 0 degrees and the measurement proceeds clockwise. So yeah, here is the figure for the slope. Sorry, figure for the aspect. So this is aspect, this is contour, this is slope, this is hillside, and this is digital elevation model. Thank you for watching.